dimensional analysis sample problem. It says, how many pounds does 1 gallon of mercury weigh? The density of mercury is 13.6 grams per centimeter cubed. Well, this is an interesting problem because pounds is, of course, a unit for weight, but gallon is a unit for volume. So there are two different types of measurements. The only thing that connects volume to pounds or mass is the concept of density. Density is the mass per unit volume. So without this given value here, it would be impossible really to do this. So let's set up our dimensional analysis like we've been. How many pounds is equal to 1 gallon of mercury? I'm just going to write GAL for gallon. Now, we've talked about this before. We've talked about how when you're trying to get from one unit to the next, or in this case, gallons to pounds, that it'd be great to have a direct relationship between the two. Well, again, pounds per gallon would be kind of a not true density because it would be mass per volume, but it's close enough that we would need to know the pounds per gallon of something, and that's just not available. So we have to use the density unit here to get us to pounds. Well, I'm nowhere near the concept of weight here, or the unit weight. So what I'm going to have to do is I'm going to have to figure out a lot of bridging units for me to get through this. Let's take a look at the conversion factors here. I'm trying to get gallons to pounds. And I look over here and I see that there is a relationship between quarts and liters, and that's a unit that relates metric to English. Now, why would I need something like that? Well, eventually, I'm going to have to get from grams to pounds. So I know that I'm going to have to go from the English to the metric back to pounds. So when I look at the conversion factors, there's one connection that allows me to get from English to metric units. Another thing that I have to consider is once I get to English, how am I going to get, once I get to metric, how am I going to get back to English? Eventually trying to get to pounds. Well, I see here that pounds and kilogram are related, and I know kilogram is metric, so if I can get my mass to grams, then I can go from kilograms to pounds. What am I going to do in the middle of all this? Well, I'm going to have to deal with these volumes. So let's see how we're going to work it out. Gallons on the bottom. And again, I go to my conversion factors. And I look to see where I have gallons available to me. I look all through here. And really, I see gallons here. I see barrels with gallons. But barrels is not going to get me anywhere. I do see quarts. And down here, quarts goes to liters. So there's a connection between gallons and liters. So let's do that. Let's get the quarts first. And every 1 gallon has 4 quarts in it. Cancel my gallons. Now, can I get from quarts to liters? I can, because I know that 1.1 quart and a liter are just about the same. So what do I put next to liters? I put a 1, because there's a 1 there. What do I put next to quarts? I put a 1.1. Just about the same size. Okay, quarts cancel. Now I'm at liters. And remember, I'm trying to get to centimeters cubed so I can get to grams and eventually to pounds. So liters goes on the bottom. Is there a connection between liters and centimeters cubed? No, but there is a connection between centimeters cubed and milliliters. They are the same thing. So if you have 1 centimeter cubed, you have a milliliter. And if I can get to milliliters, I can get to centimeters cubed. Well, where am I right now? I'm at liters. So I'm going to put milliliters there. Which one's a bigger value? Liters is bigger. So I put a 1 there. How many milliliters in a liter? Well, liters is 10 to the 0. Milli is 10 to the negative third. How far are we talking? 10 to the third. What's another way of writing 10 to the third? 1,000. Liters cancel. Now, milliliters on the bottom. Can I get directly to centimeters cubed? I can. In fact, I could even skip this bracket, but I'm not. They are 1 to 1. Now, earlier we talked about exponents and how when you're dealing with exponents, you typically have to cube or square your conversion factors. Well, the connection between centimeters cubed and grams, the cubed has already been accounted for. So I can go directly from centimeters cubed to grams because I'm given the density. Remember, the value 13.6 is a conversion factor. 13.6 grams for every 1 centimeter cubed of mercury. That right there is a conversion factor. So I can go from centimeters cubed directly to grams without having to worry about cubing anything. So what numbers am I going to put? Well, for every 1 centimeter cubed, there's 13.6 grams of mercury. Centimeters cubed cancel. Now I'm at grams. And again, we're trying to get to pounds, remember. Is there a direct correlation between grams and pounds? No. But there is between kilograms and pounds. So can I get my grams to kilograms? I can. Which one's bigger? A kilogram. Grams are 10 to the 0. Kilos 10 to the third. How far are we talking? 10 to the third or 1,000. Grams cancel. Now can I get from kilograms to pounds? Well, I look on my conversion sheet and I see 1 kilogram for every 2.2 pounds. 1 kilogram, 2.2 pounds. Kilograms cancel. Where do I want to be? Pounds, right? Where am I right now after everything's canceled? Pounds. Do I need to make any more brackets? No, thank goodness, because I'm out of room anyway. And now it's just a matter of multiplying all the way across the top and dividing. So let's get our calculator. And we're going to multiply 4 times 1,000 times 13.6 times 2.2. So 4 times 1,000 times 13.6 times 2.2 divided by 1.1. And we're dividing that by 1,000. And I end up with 108.8 pounds. That's not rounded yet though. So we go back and we look at our values. Now the given value here was exactly 1 gallon. So the 4 quarts in gallon is exact. The 1,000 to 1, the 1 to 1. The 1 to 13.6, so we're going to treat that, because it's a decimal number, as a measured value. So that's 3 sig figs there. There's 2 there. Again, decimal number. 2 there, 3 there, and 2 here. So I'm going to go with 2 as my least number of sig figs. Which number is the second sig fig? The 0. It's next to the 0. An 8, so the 0 is going to go up to a 1. And I got to keep the place value consistent. So I'm going to add a 0 there. Pounds. And there's my answer, 110 pounds. So this means that if you have a gallon of mercury, like if you had a gallon of milk, but instead of milk you had a gallon of mercury in there, it would weigh 110 pounds. Hard to believe, but mercury, pretty dense. All right, that's the last dimensional analysis example.